Welcome back to the Deep Dive. Today, we are focusing our attention on a platform that promises to take one of the most soul-crushing realities of modern office life repetitive digital work and simply wipe it out.
Yeah, we're talking about Pendless.
An AI-powered browser automation system. It's designed to take these really complex web actions and just execute them from plain English instructions.
And this guide is so timely because for years the conversation around AI has been dominated by this deeply human fear.
That the machines are coming for the thinking jobs.
Exactly. But Pendless operates on a completely different and I think healthier premise. They argue we should focus AI on removing the boring jobs.
So ones nobody wants anyway.
Right, the mechanical, repetitive tasks that just drain human energy and creativity. The mission here isn't displacement, it's amplification.
Amplification is definitely what's needed. I mean, the source data we have just screams this urgency. We're talking about highly skilled workers globally sinking serious, irretrievable time into what is, well, it's essentially mindless digital labor.
Let's put a number on that. The average worker spends 581 hours per year on these repetitive digital activities.
Just take a minute to absorb that. 581 hours. That's over 72 full workdays.
More than 2 months of working time.
And it's all going to copy pasting, updating spreadsheets, or filling out the same forms week after week. If you're a professional listening to this, you know exactly where those hours go.
And people know it's inefficient. A staggering 60% of people surveyed believe they could save at least 6 hours every single week.
If only they had the right tools.
Right, if they just had access to proper, reliable automation. The intent is there, but the tools to fill that gap, especially for smaller players, have just been historically out of reach.
So that is our mission today.
Mm.
We are going to deconstruct exactly how Pendless works to bridge that enormous gap. We need to understand how this system takes your casual, natural language and translates it into reliable web actions that actually run.
Without requiring heavy coding or, a huge IT infrastructure.
Before we jump into the solution, we have to look back at the existing landscape, specifically the technology that came before Pendless, Robotic Process Automation, or RPA. Now, RPA promised the world, but the source material is pretty clear about why it failed to get, widespread adoption.
Well, RPO fundamentally works by scripting explicit mouse movements and keyboard actions. It's like recording a macro, but for your whole system. And the core issues were cost, rigidity, and what we call fragility.
Explain that fragility, because that seems like the central flaw. If a business invests so much in automating a process, why does it break so easily?
Because traditional RPA relies on hard-coded selectors. So if the target website changes its layout, if a button moves from the left side of the screen to the right.
Or a form field name changes.
Exactly. The entire expensive automation pipeline just breaks immediately. You have to hire a developer to spend days rebuilding and retesting the script, all while paying these hefty annual license fees.
And that creates a massive, expensive barrier to entry. We're talking about highly operations-driven small and medium businesses, the SMBs, that are incredibly competitive.
And yet the research shows only about 20% of them have implemented any kind of RPA solution.
They're locked out.
Completely. Locked out by the complexity and the poor, unpredictable return on investment.
So Pendless was conceived to serve the other 80%.
Right. Their core vision isn't some heavy system-level architecture. It's a simple AI-powered robot that lives right there in your browser. It has to be fast, reliable, and able to dynamically interpret changes on a web page using AI.
So the automations don't just shatter the second a developer tweaks the CSS.
Oh, precisely. The stated goal is really compelling. Automation should amplify people, freeing teams from repetitive work so they can focus their attention on creative problem solving and strategic planning.
And to do that, they had to make a really foundational architectural choice.
They chose to build Pendless as a Google Chrome extension, which is a surprisingly elegant decision. They explicitly rejected the heavyweight approach of, building a separate desktop robot or forking a whole browser like Chromium.
Why? What's the advantage of the extension?
Simplicity. The extension approach lets them leverage Chrome's native code injection capabilities. This allows for simple, direct, real-time interaction with the elements on the web page.
Okay, so let's pull back the curtain on this architecture. It's a smart 4-layer design that, from what I can see, neatly separates the UI from the heavy lifting.
And crucially, from the AI stabilization, we can start with layer 1, the one closest to you, the user. the Chrome extension side panel.
This is your command center.
Your UI, yeah. It's
Well,
organized for efficiency with 3 tabs.
Right. You have the chat tab, which is where the magic starts. It's your conversational interface for telling it what to do. Then the queue tab, which is just a list of tasks.
Waiting to be executed or currently running.
And finally, the gallery, which is essentially a library for your successful pre-tested prompts.
For instant reuse. Then, moving deeper, layer 2 is the automation engine. This is the critical bridge. Once the system knows what to do, this engine injects the automation code directly into the target page.
Which gives it direct, powerful access to the document object model, or DOM. Now, for listeners less familiar with web terminology, why is accessing the DOM directly so much better than the old RPA methods, like screen scraping?
Oh, that's vital. The DOM is the browser's structured representation of the page. So when the engine accesses the DOM, it doesn't just see a button's location on the screen.
It sees its identity.
Its identity, exactly. Its ID, its tags, its relationship to other elements. So if the button shifts 3 pixels to the left, the AI can still find it based on its identity within the code, not its physical location.
Yeah.
This is the core of its adaptability.
That makes perfect sense. Now, layer 3 is where the AI itself is managed, server-side processing.
Precisely. This server curates the information from the browser, prepares the instructions for the large language model. They confirm they're using OpenAI's completion API for the reasoning, and then, critically, it applies server-side guardrails to stabilize the AI's output.
Let's pause on those guardrails. If you're using a state-of-the-art LLM, why do you need extra processing? Isn't the temperature setting enough to control it?
You'd think so, but they found it was insufficient. This was a huge development challenge. If they tried to lock down the LLM's creativity with a very low temperature,
The instructions would be too simple.
too limited, right. It couldn't define enough complex steps. But if the temperature was set too high, the AI get too imaginative.
It would start hallucinating steps.
It would hallucinate steps, try to use commands that didn't exist, and bry the guardrails. The server-side processing is necessary to take that raw LLM output and rigorously mold it into a dependable, executable command language.
And wrapping up the architecture is layer 4, the Enqueueing API.
Which is simple but robust. This is what allows for true programmatic scaling. Businesses can just submit a URL and the action in natural language via the API, and Pendless enqueues it.
And that leads directly to their core organizational model, queue-based orchestration. Why does that simple concept, the queue, matter so much for a business user?
Predictability and accountability. In a traditional system, a bot can fail silently, and you might not know for hours. With a queue, tasks are submitted, prioritized, executed sequentially. If something fails, you know exactly when, why, and what's still waiting.
It's traceable.
It's traceable, auditable, and reliable for high-volume work. And yet for the user, all that complexity is hidden behind this smooth conversational automation interface.
You don't need to be a programmer. You just tell it what you want. Go here, extract this, paste it there. It just translates that human intent.
And the development insights on that are fascinating. They share this internal curiosity. They discovered that the most effective tool for crafting the best prompts was Pendless itself.
What do you mean?
They literally asked the system through conversations, how should I structure a prompt to make you execute this task with 99% reliability? The platform taught them how to get the most accurate output from it.
So the AI is coaching the engineers. That leads us right to the difference between agentic versus robotic behavior. It's not just a fancy term. It reflects how the system deals with uncertainty.
Correct. When instructions are perfectly clear, click the blue Submit button. Pendless acts robotically. It executes the known, predictable path.
But the web is rarely perfect. So what happens when the instructions are ambiguous, or maybe a website layout has changed?
That's when it shows agentic behavior. Instead of just failing, the AI will perform intermediate context-aware actions. It might browse the page, monitor results, look for alternative buttons.
Or even ask for help.
Or prompt the user for feedback. Yeah, I found 2 forms. Which one should I fill out? This ability to navigate uncertainty without outright failure is what makes it so much more resilient.
We absolutely need to address performance and security. 30 seconds seems fast, but is that consistent?
Right now, complex tasks execute in roughly 30 seconds. Maybe most of that, maybe 90%, is just API latency waiting for the LLM. As LLMs get faster, that time will drop significantly.
But the real game isn't the raw speed.
It's the consistency.
Yeah.
Automating a task that takes a person 5 minutes with a high risk of error and replacing it with a predictable 30-second execution. That's a huge operational win.
And on security, for a tool living in your browser, potentially handling sensitive data, privacy is paramount.
It is. All communications and storage are encrypted. But critically, conversations and the data in them are not stored by default by Pendless.
So it's a secure, temporary workspace unless you opt in.
Exactly. That's a fundamental privacy control that users have to enable, specifically if they want history.
Now, while it's powerful, there are natural constraints when you operate strictly inside the browser. We should be clear about those limitations.
Absolutely. The source material lists three primary constraints. First, because of browser security policies, Pendless can't access content inside cross-origin iframes.
That's a standard security barrier, but it can limit interactions with certain embedded third-party tools, right?
It is a functional constraint, yes, but it's a non-negotiable security trade-off. Second, the system currently cannot interpret or extract information from images or PDFs on the page.
It reads the text of the DOM, but not visual media. Not yet.
Not yet. And finally, some highly protected websites intentionally use synthetic interaction protections that can block any automated input, no matter how smart the AI is.
Okay, let's move to the practical application. Now that we understand the tech, where does this actually create measurable time savings? The use cases seem to fall into four conceptual axes.
The first is simple: read-oriented tasks. This is pure data extraction. For example, automatically collecting product prices or availability across dozens of competitor sites.
Saving an analyst from hours of mindless clicking.
Right. And the second axis is the opposite: right-oriented tasks. Pure data input. Think of high-volume clerical work like updating inventory status across several e-commerce platforms.
Or submitting those multi-page financial reports to a government portal.
Yes, it drastically reduces manual error and just accelerates throughput.
The third, and this seems to be the most valuable, is the combined read and write workflow. This is where that agentic behavior really shines.
It is. Imagine managing customer relations. Pendless could monitor support channels. That's a read task. It then extracts all reviews with a low sentiment score, a filtering task.
Then it analyzes the specific problem mentioned in the text.
A reasoning task. And finally, it uses that data to automatically open your CRM, find the customer, and update their status with the ticket ID and a summary. A write task.
That entire tedious multi-step process, which used to take a human 20 minutes of context switching, is now just done.
That's where the 581 hours a year are saved. And the final axis is web application interaction. This moves beyond simple forms into complex interfaces, like QA teams doing automated regression testing.
Or sales teams interacting with those multi-tab dashboards.
Exactly. It extends automation to environments that were traditionally considered too dynamic for simple bots.
When we place Pendless alongside its alternatives, its comparative advantage really crystallizes.
Let's recap them. Traditional RPA requires heavy infrastructure and explicit scripting. It's broad, system-level stuff. No-code tools like Zapier are cloud-based, but limited to a finite number of predefined connectors.
They struggle with any website that doesn't have an API.
Right. But Pendless sits in a totally different category. It's a lightweight Chrome extension, uses a conversational interface, and most importantly, it runs in the browser using your authenticated session.
And because it uses AI to read the DOM, it adapts. It's less brittle.
And we have data to quantify this. Pendless ran a head-to-head benchmark against a competitor, Perplexity's Comet browser agent. The results really speak to the stability of their architecture.
Let's look at the speed gap. The average execution speed for Pendless was 23.4 seconds per task. Comet took 2 minutes and 13 seconds.
That's an exponential difference in throughput.
And beyond speed, there's reliability. Precision, the percentage of steps done correctly, was 97.2% for Pendless versus Comet's 93.3%.
And recall, the percentage of all required steps fully completed was 97.9% for Pendless versus 93.6% for Comet. In complex automation, those few percentage points are the difference between a reliable tool and one that just generates constant headaches.
Looking ahead, the future roadmap confirms this platform is growing fast. They're planning shared prompt galleries for team collaboration and working on interpreting images and PDFs.
They're also planning deeper third-party tool integrations. But the most intriguing item on the roadmap for me is the planned introduction of the optional local relay.
And that is our concluding thought for you to chew on today. This local relay wouldn't be mandatory. It's an OS-level helper that a user would explicitly have to authorize on their own machine.
And its purpose is to allow Pendless to send authenticated input orders to synthesize native mouse and keyboard events.
Why is this such a big deal?
Because right now, highly protected sites like certain banking portals can block any synthetic input that comes from a browser extension. This local relay, by synthesizing OS-level clicks and keystrokes, effectively bypasses those browser-level protections.
So, if they achieve this, the system will have the authority to act as if a human hand is physically operating the computer, even on the most protected sites. The question this raises is, how will this ability to synthesize native OS-level input fundamentally change how we view the boundary between web automation and desktop automation?
When an AI in your browser can bypass browser restrictions to mimic human input at the OS level, what is left to protect the system?
Think about that until the next time we dive deep.